Now this one's kind of interesting. This one's, sometimes you have to go back to the inputs and outputs. So remember the input, the output. Let's use, I think the point 1, 2 would be a good input. Then what vector is outputted? And it might be helpful to convert to component form. In component form, the vector negative yi plus xj has components negative y, x. So if you put in an input of 1, 2, what would the output look like? Yeah, negative 2, 1. So if my input point is over 1 up 2, then my output, I treat that input point like my 0, 0, like my origin. And then I just, from that origin, I draw my vector. From that tail, I draw my vector. So I go left 2, 1, 2, and up 1. And get that. And here's the thing. If you draw the original input as a vector, not that you would for the vector field, but if you draw the original input as a vector, what do you notice about this guy 1, 2 as a vector and the vector negative 2, 1? What about their dot products? If you thought of this point as a vector, what would their dot product be, the input and the output? Or just look at the picture. What does it look like the relationship is between the input, if you drew that as a vector, which you don't normally do, and it looks like they're perpendicular. And in fact, if you take the dot product of the vector x, y and the vector negative y, x, then you do get 0. And so the input, if you consider it a vector, and the output vector would be perpendicular to each other. So what does that mean? Well, if you drew a circle of, let me kind of start over here. If you drew a circle, then any, a circle centered at the origin. So let's go with a circle of radius 2, because it's a nice size to draw. I want you to realize something. The magnitude of any output point is going to be the same as the magnitude of the input point. So if you took the magnitude then of f, that would be the square root of y squared plus x squared, or x squared plus y squared, right? And if you think about it then, any point on this circle as an input point, when you plug it into the vector field, it would, first of all, be perpendicular to any point on the circle, and it would have the same magnitude as the radius of that circle. The square root of x squared plus y squared is that radius, right? So if the radius is 2, then the length of this vector here, first of all, it'll be perpendicular, if you think of the input as a vector, this being the input, it'll be perpendicular to that vector, and it will have the length, the same radius of this circle. So that every vector on this circle has the same length and is perpendicular to this circle. So for a circle of radius 2, any, and I could draw it anywhere, any vector with input on that circle is going to have length or magnitude 2. And this is really a special vector field. It's the vector field of uniform motion. Think of a point on a wheel.